Hello, we're Team 7 studying Burj Al Arab. This week's presentation was accomplished by following minor roles: Research and Study on Foundation Issues by Oh Jung-hoon, Park Tae-rim, Bung Woo-jin. Presentation by Gong Tae-won. Provision of Review Episode Preview by Yoo Jung-ho. As always, each team member is fully participating in our study with their major roles and distributed minor roles. With that in mind, let's begin our presentation. Our fifth week's presentation will continue with the following contents. Starting from a brief review about what we've introduced last week, then moving on to this week's episode and construction solution about the engineer's concern on the foundation. Lastly, we'll end our presentation with a preview about what we will be studying next week.
Last week, we've looked upon a huge clash between architect Tom Wright and engineer Mike McNicholas. The clash was about the artificial island's height. Tom Wright wanted the hotel to be the world's best vacation spot, and this was possible only when the island's height was low and close to the sea. On the other hand, engineer Mike McNicholas was worried about safety. As Dubai is located at the major fault line, the shore had high waves, and this could endanger both the guests and the building. Therefore, raising the island's height was inevitable. The result was surprising. Tom Wright won the conflict. How did they solve the problem? They installed shed units along the whole island to act as a seawall. Shed units work with friction between adjacent units, and their size and weight are 3.375 cubic meters and 200 to 250 kilograms respectively. How to install them? It starts with flattening the rock core by stacking small rocks called underlayer. Toe structures are essential to support the whole shed units from the bottom. Every shed unit were moved one by cranes and placed specifically by drivers. Lastly, the spaces that occurred by the curved geometry of the island were filled by spacers. This is what we've studied last time. Now then, what are other construction problems with Burj Al Arab? After solving the problems with the high waves and when the shape of the artificial island was almost in place, the engineer had another concern. It was about the foundation. Like any other normal building, they needed to dig the earth for the foundation construction of the building. Skin friction piles were already inserted for the stability of the island, as we've mentioned in our second presentation. They need to excavate the sand until the skin friction piles are exposed. Then cure the concrete slab and finish the foundation. However, a problem occurred. It was about water pressure. As it is an artificial island, water lies around the entire island. As the sand in the center of Burj Al Arab's artificial island decreases, the weight of the center also decreases. A difference in water level between the center and the outside occurs. Then the seawater tries to flow to the center of the island through the underground. It could result in the center of the island bouncing like a cork stopper because of high water pressure and endangering the workforces and excavators inside. This effect is called the boiling effect. Mike McNicholas had to solve this boiling effect that occurred by the water pressure.
Let's see how they solve this problem. There is a difference between a normal artificial island and Burj Al Arab's artificial island. Normally, when building an artificial island with nothing on it, engineers have no concern with water pressure. They only need 3 steps: soil bed preparation, sand placement, and dredging. But Burj Al Arab is a different case. They need a solid foundation, and for this, they need to excavate the center of the island, which means the loss of the force to endure water pressure. In conclusion, the engineers constructed the slab layer by injecting cement seal through cofferdam made with steel. This layer prevents seawater from rising to the foundation level and is also waterproof. Unfortunately, our team worked hard to find out what techniques were used to construct this waterproof slab layer, but couldn't find it. Therefore, we've studied plausible methods that could be applied in constructing Burj Al Arab. The methods are the jet grouting methods and bottom grouting with a temporary sheathing method. Firstly, jet grouting method is a type of construction in which the ground is cut using ultra-high pressure air jet and the injection is sprayed at high speed to replace the cutting part with soil or mix it with soil. The method claims in the increasing the bearing power of the foundation. Bottom grouting with a temporary sheathing method is applied by installing a sheathing slab to prevent heaving failure generated in poor ground. We thought that Burj Al Arab was constructed in a similar way to these 2 construction methods because it must prevent the sand boil. The construction method we've studied are like this. It starts with excavating with a long pipe as the jet grouting system does. When the pipe arrives at the level where the slab layer is to be constructed, the air or water is injected to construct a place for a cement seal, and the cement seal is injected to form a slab. This cement replaces the weight of the soil and acts as waterproof. This method is repeated until the whole slab layer is filled with the cement seal. This would end up looking like this from the above. The cement seal is placed in all areas. This creates a slab layer below the base that can withstand the pressure of the seawater. Burj Al Arab constructed this slab layer before they started excavating to prevent sand boil that could happen afterward. Successfully solving water pressure problem, Burj Al Arab's artificial island is now at its final stage. They start the excavation of sand until the skin friction piles are exposed. When the piles are exposed, they place concrete slab which would be the 3rd basement floor of Burj Al Arab. Then the piles that are exposed above are dismantled. This completes Burj Al Arab's artificial island and base construction. To summarize, the artificial island built slab layer with cement seal to prevent boiling effect by water pressure and excavated sand until the pre-installed piles were exposed, then dismantled them to create a smooth basement floor. Through 3 times of presentation, we've explained the construction of Burj Al Arab's artificial island and the foundation. Next time, we'll finally begin the construction of the main building. In our next presentation, we'll look upon the Burj Al Arab's unique core shape. As it should be the world's best vacation spot, the building's form is extraordinary, resembling a shape of a yacht. To bring this ideal yacht shape into realization, let's see how the core of Burj Al Arab was constructed. Thank you for listening.